The arm or the upper limb is really quite easy at the very beginning at the proximal portion. We've already discussed quite a bit about the deltoid, the pectoralis major, latissimus dorsi, teres major, minor, um, infraspinatus, supraspinatus, all these other muscles that have some type of effect and pull on the upper arm. Let's go ahead and talk about the muscles proper that are indeed portion or part of that upper limb, beginning with the most frontal portion, that biceps brachii. Breaking down that word, biceps, bi means two, so it means it has two origin points. Brachii meaning that it has it's part of the arm, so hence biceps brachii. Both of these tendons, these origin points, have their own long head, short head associations with fascia, but we're not going to get into much detail about that here. We're going to go ahead and let's go ahead and peel. If we were to peel away that biceps brachii, you would find underneath something called the brachialis, which is a synergist to that biceps brachii. Turning around this individual, you will find a triceps, again because, well, it has three heads, a long lateral and medial head, all working together to work towards extending the muscles at the elbow joint, as well as if we consider that it has that origin point at the scapula, it can have some extension over here at the shoulder. Cross-section of that muscle, you can see all the nerves and blood vessels that serve this portion of the muscle. Do you need to know this cross-section? No. Moving on. This picture right here, yes, you do need to know, because it is really quite helpful because it pulls away a lot of the muscles that would be in the way, otherwise would be in the way of being able to see these muscles. The brachialis, again, we have that biceps brachii torn away. You can see that its origin point is on that humerus with its insertion point wrapping around down into the forearm. The brachioradialis, which is your most lateral muscle of the forearm, it has a lot to do with innervating and moving that, or pulling that hand away from the medial line. It's there, but the ones that I really care about, because I really love the analogy of the soup and the pro, the soup being awful and the pro showing why it's awful. The supinator, pronator. Supinator, remember, is to help bring your hand up as if you're supporting some soup. The pronator is pouring out that soup because the pro thinks your soup's awful. Now, to help you understand and really remember how this goes, you can look at the insertion and origin point. That supinator, we are at a posterior deep view. We've cleaved away a lot of muscle to see this. You can see that it's coming around and has inserted into that ulna. That ulna is pretty stationary because of that olecranon process, olecranon fossa, and has wrapped around. You can actually, how you can tell how it will roll is you will put your thumb on the origin point and pretend that your pointer finger is this insertion point. It doesn't have to be in the exact insertion point that you see with the supinator though. But you can rotate. If you were to try and draw your finger, that humerus, or not humerus, I did it again, that radius towards that origin point of the supinator, you would see that you would have your hand asking for soup. The pronator teres and pronator quadratus work together to pronate and pour out that soup. Again, you can follow that origin point. You can see it's on that. Here's the medial aspect, so the medial condyle of that humerus with an insertion point onto that radius. If you were to squeeze your finger around that humerus, or I did it again, that radius, and pull on it, you would see that you'd be pouring out that soup like a pro. Pronator teres, pronator quadratus because it's there in a square form, and it does help, in fact, cause that pronation by tugging. It's wrapped in such a way that you can't really see in this picture, but it's wrapped in such a way that it helps really make that movement go. Digging into the forearm, there are a lot of muscles in the forearm, which should make sense to you because, well, there are a lot of things that you do with your arm. You do a lot of movement, finger movements, you do a lot of typing and all that stuff. They all need to work independently, and you have to have the agonists, synergists, and antagonists all working to help you do your thing. For us, that we are not going into this much detail. This is just almost too much. We're going to go ahead. This is an anterior aspect. This is just the anterior view of it all. The portion on the left is having all of them still intact. You can barely see that pronator teres right there, sneaking out with the superficialis, not the supinator not even being seen until you pull away this brachioradialis out of the way. So the brachioradialis is the muscle that is the most lateral portion. You see that it has a nice insertion point into those carpal bones. Moving onward, you will see this muscle right here called the flexor carpi radialis is a major landmark for you, not because of what it does, but because of what goes by it. This picture doesn't really show it because, again, we don't really want that much detail that is already there. That's already too much detail here. But if you were to put your finger next to that tendon right here nearby the carpal bones, or just below, just more proximal, you would find that you have yourself a radial pulse. So that tendon, that very first tendon that you feel, helps act as a landmark to that radial pulse. If we were to cleave away the flexor carpi radialis, and look just a bit deeper, you would find the flexor digitorum superficialis. Let's break down that word really quick. Flexor, so it's doing some flexing. It's causing something to go forward into that, past that anatomical position. Digitorum, well, that sounds like digits, so it's working with the fingers. Superficialis, so that must mean that it is the superficial portion. There must therefore be a profundus. And what do you know? Flexor digitorum profundus, there it is, right there. These flexor digitorum superficialis, and profundus do not have a branch from them onto the thumb. The thumb has its own way of working, which actually you can see quite a few of these tendons going on merely by wiggling your thumb around back and forth. We're not going to go ahead and dive too much into that. We're just going to switch over to the posterior portion, take a look-see at it. There's that brachioradialis again that you can barely see. Right there. Oh no, I lost it. Well, anyways, not a huge worry, not a huge concern. What we care about back here is these extensor digiti minimi, meaning that you only have one set. If you extend your fingers as much as you can, you should be able to see the tendons that work with them. With that, now you should also be able to explain why when somebody is getting electrocuted because they are holding onto an electric wire, how they are never able to let go. Remember that sodium charges into the cells that cause the contractions and to release calcium out. You have two flexor digitorums and one extensor digitorum. Those two flexors are much stronger than just one single pair of these nice slender flexor or extensor digitorums. So you would never be able, the extensors would never be able to overcome the force that is the flexors. You will notice also that a couple of other muscles that are dealing with the pollicis. So remember, the pollicis was just a fancy pollicis, which is just another fancy way of saying thumb. If you were to draw out or move away your thumb from the rest of your hand, you would see one tendon rise prominently from it. It is the one that abducts your thumb away. So it is your abductor pollicis longus. If you were to extend that thumb, meaning that you were trying to push it, if you're back in anatomical position, you're trying to push that thumb backwards behind you, you would see another tendon rise. That is let's take a look, see, and there's the tendon right there. Yes, the extensor pollicis longus. Yay for superficial anatomy. Making this thing a little bit clearer. One thing to note, you will see that the flexor carpi, not the flexor carpi, flexor digitorums do go underneath and enter underneath a flexor retinaculum, which helps bundle these things together and make certain that you don't have any issues. But by having repetitive motion, those people that type all the time, or those that are doing a repetitive jarring motion with their hands, will notice that these things can get inflamed and pushed down on this particular nerve right here that's labeled 1, that median nerve. That median nerve can become inflamed and painful, and that serves to innervate a lot of your digits and a lot of the more medial aspect of your arm, so you can have radial pain in that way. With that, that is the end of our discussion of the upper limb and the muscles that we are going to discuss here. And we'll be going back to our discussion of the lower limbs here in a little while. Remember, you got this.